Hello students, welcome to classroom teaching. In last session we discussed about the concept of resistance and resistivity. We know that resistance, it is nothing but two-ended equipment. We know it is nothing but two-ended equipment. This is the symbol of resistance. And within these two ends a particular value is provided, that is nothing but, suppose it is of 10 ohm resistors, that means the value of 10 ohm it is provided between its two ends. You can see how the actual resistance it looks like in this video, and also we know that in our house there are so many electrical equipments, so many gadgets we are using, and for each and every equipment different amount of electric current is required, and resistance we use to control the current. That means if we require a particular amount of current, then we have to use these resistances in that circuit to get that particular amount of current. And therefore, to get a particular amount of current through the circuit, flowing through the circuit, we require different combinations of resistances. So what are these combinations that we are going to see today? So there are two main types of combinations, that is resistances in series and resistors in parallel. So let us discuss one by one. First, resistors in series. Resistors in series combination. So what is the actual meaning of series combination? Series means one after another. We know resistance, it has two ends. If we combine so many such resistances, no problem if you connect two resistors or three resistors or four resistors. But if we combine them one after another, that means head to tail combination we can say. So in this way, suppose I connect one another resistance here, one another resistance here. So this combination, suppose this is R1, this is R2, this is R3 resistance. So these three resistors are said to be connected in series combination. These are in series combination. So there are two criteria to find out whether the combination is series or not. Look, first, all these resistors, they must be connected in one line in the way head to tail combination. So it is there. But if I connect one resistor here, suppose it is R4. So whether this resistance is connected or whether these two resistors they are connected in series, because actually it is also head to tail combination. So to find out, the second criteria we have to use, which is that the same amount of current should flow through it. What is the meaning of that? Let us complete this circuit first. We connect ammeter here to calculate the current, then a tap key is connected in series also, then we connect a cell or a battery here in this way, and so if we connect, let us forget this. So if we connect battery in the circuit and if we close this key, then definitely current flows from positive to negative, and that means the current flows in this direction. So this should be the direction of current. Suppose this is point C, this is point D. So current is flowing from C to D. Suppose the amount of current flowing through it I, that we can measure it in ammeter. So I amount of current is flowing through this R1. The same current is flowing through R2 and the same current is flowing through R3, and therefore we say all these three are in series because same amount of current is flowing through it. If I connect R4 in this way, now the I current is flowing up to this point only. At this point it has two ways to go. From this I, suppose it is 10 ampere. From this 10 ampere, some amount of current it flows through R4 and some amount of current flows through R3. So whether the current flowing through all these four resistors, whether it is same? No, and therefore such combination is not called a series combination. So two criteria: head to tail combination, that means all the resistors they should be connected one after another, and the second criteria that we are going to use is same amount of current is flowing through the all resistances. Then all these resistances are said to be in series combination. So this is nothing but series combination. R1, R2 and R3, they are connected in series because same amount of current is flowing through them. And now they are in series. So why this series combination is used, or what is the equivalent resistance of C and D point, between this C and D point? All these, this is R1, this is R2, this is R3, but what is the resistance between C and D? This combination. Connect a potential, to measure potential difference, connect voltmeter here. So if we connect voltmeter here, then we can measure the potential difference between R1. So it should be, suppose it is, we take it as V1. Suppose the V1 is the potential difference between R1, within R1, that means between these 2 points. If we connect the same voltmeter here, then we get different amount of potential difference. Suppose it is V2. And suppose if we connect the voltmeter here, then we get the potential difference V3. Current is same through them. We can use Ohm's law here. And we get V is equal to V1 plus V2 plus V3 in this case. What is V? V is the potential difference between C and D, these 2 points. If we connect the potential voltmeter here between these 2 points, then we get the V potential difference, which is equal to V1 plus V2 plus V3. Only 2 points that we are going to see here. First, V is equal to V1 plus V2 plus V3. This is first equation. And the second equation, I is equal to I1 is equal to I2 is equal to I3. So what is I1? I1 is current flowing through R1. What is I2? Current flowing through R2. What is I3? It is current flowing through R3. So, and all they are equal, that means it is I, because there is no another way for electric current to flow through. So I is equal to I1 is equal to I2 is equal to I3. So if we use Ohm's law, what is Ohm's law? Ohm's law is V is equal to IR. It is Ohm's law. So what is V1? V1 means potential difference across R1. So we can write V1 is equal to I into R1. V2 is equal to I into R2, because I is same current is flowing through them. What is V3? I into R3. We are just using Ohm's law here for each resistor. But we know V is equal to V1 plus V2 plus V3. So keep these values of V1, V2, V3 in equation number 1. So what we get? V means I into R. Here we take RS. What is RS? It is nothing but the equivalent resistance of series combination. We are taking series combination here. So the current flowing through it is I. What should be the resistance? It should be RS. We have to calculate this value. आपण याची value calculate करतोय. So I into RS is equal to V1 plus V2 plus V3. So V1 is IR1 plus IR2 plus IR3. So this I get cancelled out. If we take it common, then we get RS is equal to R1 plus R2 plus R3. So we have taken 3 resistances in series. So the equivalent resistance of the combination, it is nothing but addition of all these 3 resistances. What happens if we take, instead of 3, if we take 4 resistances, then RS should be equal to R1 plus R2 plus R3 plus R4. If we take n resistances, then it should be equal to R1 plus R2 plus dash 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 up to Rn. So many resistances we can use there. So what is the meaning of that? We get this formula. I will rub it here. So if I have resistances of 10 ohm each with me, so what we get in series combination, equivalent resistance Rs, it is equal to R1 plus R2 plus R3 plus dash 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 up to Rn. Students, I have resistances, 10 such resistances I have, each of the same value of 10 ohm. That means I have all the resistance with me which have the value of 10 ohm. And in circuit, if I require the resistance of 70 ohm, then what should I do? I have to arrange 7 such resistances in series so that I can get the equivalent resistance of 70 ohm. So this is a simple combination that is called a series combination. Where it is used? This combination is used to increase the resistance of the circuit. What are the main points of this combination? In series combination, I, that means current flowing through all resistances, it must be equal. The second point, V is equal to V1 plus V2 plus V3. That means the potential difference across two ends, it must be equal to the potential sum of the potential differences across each resistor. And the resistance of the combination, that is nothing but the effective resistance of series combination SRS, it should be equal to R1 plus R2 plus R3 plus R4 up to Rn. So this is about series combination. So we will stop here for this series combination. In next video we will discuss about parallel combination. So you can see how the series combination can be done in this video. So we will stop here. Thank you very much.